I'm Filomena Sendello. I work here. And I am very honored to have our international speakers today. And I thank the GEL organization, the University of Campinas, and also the FAPESP project DACILAT, who works with corpora annotation and automatic translation, not using artificial intelligence. So this is important. So I'm very glad then to introduce to you Leonel from the University of Fortaleza, Ceará, and he is from Computational Linguistics. And our speakers, he is going to talk more about it, but they did the formation in computer science and then PhD in linguistics. So I thank you, everybody, and I hope we have a very nice and productive discussion today. Leonel, thank you. Please introduce
yourself. First of all, I would like to thank the Shell for the invitation for me to act as moderator of this joint talk. No? I would like to, and also to Filomena Sandals, for who is project leader of DACILAT, for inviting me to join the project and to suggest my name as debater of this joint talk, of this round table. I would like to say some words about Magda Shevchikova, is this correct? And Daniel Zeman, or Zeman. Both are researchers from the University, Charles University in Prague. They are computational linguists with the Faculty of Mathematics and Physics. Formal and applied linguistics is part of this faculty at Charles University. Yes. Okay. So, should you sit? No? So, Daniel Zeman is a research associate at the Institute of Formal and Applied Linguistics of the Faculty of Mathematics and Physics. He has a large list of publications in international journals with some thousands of citations because he's a co-founder of the Universal Dependencies Consortium, which is probably the largest endeavor in the field of treebanking. He has many. He was awarded some fellowships for Maryland, another University of Pennsylvania, Johns Hopkins University, and Magda Shevchikova is also a computational linguist. She does research on word formation, dependency syntax. She's also a research associate at the Institute of Formal and Applied Linguistics, and has also many papers in very important journals on these research fields. So I will now pass the word to my colleague.
Okay, so thank you, Leonel, for nice introduction, and thank you for having me here. It's a privilege to be here in Brazil and able to talk about my work and the work of my colleagues. Actually, I will mention that there's a large community behind what I will be presenting. So, as this roundtable is about linguistically annotated resources, I will actually focus mostly on one of them, and Leonel has already mentioned it. It will be universal dependencies. So, some of you may have heard of it. I will definitely introduce the thing. So what is universal dependencies? If you look at the website that the project has, it will, now I'm citing actually what's on there. It says that it's universal dependencies, or UD, is a project developing cross-linguistically consistent tree-bank annotation for many languages with the goal of facilitating multilingual parser development, cross-lingual learning, and parsing research from a language typology perspective. So there's a lot about parsing. That was originally really the motivation for UD was in natural language processing, but I will try to convince you that it's quite useful for linguistic research as such. And so, as we said, it's a project, but it's also several things that are behind the project. So it's an annotation scheme for annotation of many languages. It's a data repository where you can get corpora, treebanks annotated according to that scheme, and it's, last but not least, it's a community, growing number of people who are working with UD, providing the data, or just using it. So to very quickly demonstrate what you can find in the data, or what the annotation scheme means, it's for tree banking, so it's for corpora, where you have essentially syntactic but also morphological annotation of the language data in as many languages as possible. So there are, like, the basic design decisions are that word is the main annotation unit, even though sometimes it's not easy to define what is a word in some languages. And there are binary directed relations between words, and those are, we call them dependencies, but we'll see that some of them are not dependencies really in the strictly linguistic sense. So there are, besides dependencies, there are part of speech tags. So on that diagram, it's the blue line for each word. Then there, for some words in some languages, there are morphological features that are the red things here. And then there are the syntactic relations on top of the words. I also said it's a data repository. It's ever growing. We have 2 releases every year. We started 10 years ago with just 10 tree banks for 10 languages. Right now, with the most recent release we've had this May, we have 161 languages covered to various degrees. Like, not all the languages have significant, sizable data. The languages are from 31 different families, and there are 283 tree banks actually, so that means that for many languages, including Portuguese, we have multiple different data sets, and there is right now over 600 contributors. So that's the community I was talking about. The community actually is, like, you can think of it in layers. There is this core group, those 17 people on the picture there, who have been very active in designing the scheme. Then there are the tree bank developers. There's the over 600 people without whom we wouldn't have this wonderful collection of data. And then obviously there are the users of the data, and again I will later show what we believe are the typical use cases of such collection. So before I do that, I will look in a little bit finer detail at how UD looks like. So getting back to the morphological or morphosyntactic annotation, there are the part of speech tags, and the main motto of UD is that we try really to have a scheme which will be applicable to all the languages, so that if you know the scheme from, let's say, Portuguese or English, then whatever is similar in other languages, you'll be able to understand the annotation immediately. So there are these 17 coarse-grained word categories, and the assumption is that they are enough for every language of the world. So no language should have to define new categories, but it should be possible to make finer distinctions inside the category if needed for that language. And for that, we have the morphological features, for which we also have a predefined set. So these are like feature value pairs. So you have, these are just names of dimensions that you of meaning that you may want to observe in a language, but then each of them has a predefined set of values, which I'm not showing here. And not only these, I think 27 currently defined features are available, but if you need for a language something more, you can define it. So unlike the previous slide, here we really think it can be extensible, and even sometimes we will add new features to the main set of features if we see that something is used in many languages, just to make sure that people will know about it and use it the same way. As for syntax, so there are words and the part of speech here, and then there are the directed links, dependency links between words. So UD assumes that the important thing, or the most important thing about a sentence, are the content words, which should be connected first, so that in multiple languages, if you have the same construction, the trees are as parallel as possible, which means that the function words are treated as some kind of features again, because they might, in other language, they might just be translated to morphology or to nothing at all. So that increases the parallelism across languages, but also this is something that makes UD somewhat controversial in the context of other frameworks where people try to use dependencies to express syntax, because then sometimes, for instance, like finite verb might be auxiliary and will be down in the tree. So that means that the relations here are not always, not all of them are dependencies in the strictly linguistic sense. And it also means that the types of the dependencies, or the relations which are on the labels there, are really important. So it's not just about the direction of the arrows, but also about the types. Now, to demonstrate the parallelism that I had in mind when I was talking about like making content words the important members or important items here, I have an example in several languages here. So it's a passive sentence: the dog was chased by the cat, and you can see now just the blue links there connecting the verb chased to dog as a subject, the passive subject, and the cat as the oblique agent of the sentence. And now, like in Portuguese, I guess it would be syntactically very similar. We would have o cachorro, I think, perseguido pelo gato. So it would be exactly the same tree here, only for the pelo would have to be split into the preposition and the article. But if I look at a language like Bulgarian, which is the example down there, Kucheto se presledvaše od kotkata. Kucheto is the dog in Bulgarian, and here the definiteness, which is in English shown on the article, is now just marked on the noun. And then in the passive, past passive example, or past passive verb in English, there is the auxiliary was, while in Bulgarian the past is directly marked morphologically on the verb. So essentially, what is morphology in one language might be auxiliary in the other, and vice versa. So that's why we want the function words to be down as the leaves of the tree structure. I have another example in Bulgarian where it is possible to do the same thing grammatically differently, closer to English, I would say. And I have also one in Czech, Pes byl honěn kočkou, where you have no definiteness marking at all. So this is the example where you have neither morphology nor the auxiliary verb, the article. And for the cat, there is no preposition, and instead there is morphological marking for the instrumental case, which is what makes it the agent. So that was very quick, brief introduction to how the UD annotation looks like. There, obviously, I could talk about it for much longer, but we don't have time for that. Now I will try to demonstrate some use cases. So I said originally it was mostly for training NLP models. It is still good for training NLP models, but training a model which will parse you a sentence is no longer assumed to be important for end-user applications like machine translation, but it might be useful for linguists. So first of all, like the obvious use of a collection like UD is that linguists may want to search the tree banks for interesting patterns, and not just for collocations of words, but also for various more sophisticated patterns, like asking, show me a verb which has a particular type of dependent which is labeled as object and maybe is marked by a particular morphological feature, and so on. So that's the first thing. But the tree banks, most of them are not too large, so you will not find too many patterns this way maybe. But then linguists can also use the parsers to analyze more data. And the parser which was trained on a UD tree bank will not necessarily get everything 100% correct, but it will still be able to provide reasonable accuracy and analyze your data, and then you can look for more patterns there. So like in this example here, I have a Czech written Wikipedia page about COVID-19, and then it's to the right-hand side, it's analyzed in a tree structure. Then another thing which you can do with it is various applications helping language learning, because at least for me it's quite useful if I don't know a language and I want to understand something, then maybe for many languages these days we have services like Google Translate, but then I will only learn what the whole sentence means, and I don't know how it's constructed. And with a parser and with a tree structure, I can understand much more. So, and there are actually even tree banks which are specialized in learner data. So second language learners produce essays, and those are also analyzed. Another area where this collection is used is classical philology. We have a growing number of tree banks from historical classical languages. I don't even have all of them on this slide here. There's Akkadian, obviously Latin, classic, ancient Greek, and many others. And then something that I think might be of particular interest here in Brazil is we have a growing number of endangered languages being documented, including syntax and morphology captured in the UD framework, mostly because it is already easier for people working on those languages to use the framework that already exists, because there are already existing general guidelines how to annotate, so they still have to do a lot of work about figuring out how it applies to their language, but there are tools in place and there are various validation procedures, so I assume it's easier to do it within such a framework rather than from scratch. So this tree example here actually is from Guajajara, a language of Brazil. We have quite a number of languages from the Tupian family, but we have some other families spoken here as well. And we have also indigenous languages from other parts of the world. So I think this is also growing segment of UD. And then finally, something that is, I think, most related to the title of my talk is comparing languages, or using it for various studies in linguistic typology. This picture actually is not from UD directly. That's something I copied from the WALS, the Word Atlas of Language Structures. And they have, many of you probably know it, so just shortly, they have maps showing various language features in colored scheme across the world. This one, if I recall it correctly, what I took there was about the word order. So the red dots should be languages which place the object after the verb, so VO languages, and the blue ones should be OV languages. And now why I'm showing it here, because the Word Atlas of Language Structures takes this information from reference grammars or other linguistic literature. And I would claim that with a collection like UD, you can actually quantify these things. So you can take them directly from data and also say that, okay, this language is almost OV, but not as much as that language. So that's one thing that we actually did with my colleagues Joachim Nivre and Marie de Marneff, but other people have been doing similar research on UD as well. So this particular diagram here shows the languages in UD ordered by how much they are head final, meaning that the head or the governing node in a syntactic dependency is to the right of the dependent node. So the dependency relation goes right to left. So the most head final languages to the left, you probably cannot read the language codes down below the bars. The colors are done to be to reflect the language family, so at least you should be able to see that sometimes languages of the same color are roughly at the same place. And if you were able to read the language codes, you would find out that it actually supports some of the known hypotheses claims actually, that languages like Korean, Japanese, Tamil or Telugu are the ones on the left which are most head final languages, and on the other end of the scale you would find languages like Irish or Scottish Gaelic or Arabic, which are known examples of languages that have verb in the beginning, and then often the other dependencies also go that direction. One other example of a typological, or people now say typometrics, research that can be done with UD is to contrast two different typological features together in one two-dimensional diagram. So in this case, again, I took the word order example, but now on the x-axis we have object versus verb. So on the left there are languages which have almost always the object before the verb. On the right we have the opposite, verb before the object. And the y-axis does the same for subject and verb. So that means that on the in the empty top left corner we would have OVS languages. We don't have them in UD, obviously, it's empty, but it's actually known that such languages are very rare, so it's not surprising that we don't have them. And then in the lower right corner there would be typical SVO languages. Many languages prefer SVO but don't require it, so they would be somewhere in the middle. But English, Chinese are examples of what you find in the right lower corner, and in the left lower corner you would find typical SOV languages like the whole Turkic family and Dravidian languages and some others. Japanese, Korean is there as well. Okay, so now the last part of my talk is about the sort of current status of the project. So I would claim that UD has seen amazing growth over 10 years. It's here, and probably it's partly just because of luck of providing the thing that people wanted at the time, and then the snowball effect. So people have seen, the UD website have seen that there are many languages covered already, but their native language is not, and they just wanted to have it there, so they provided the data. So that's why we have sometimes just small samples of a language, but we still have it, and we hope it will eventually grow. It is used widely in NLP research, but now also growing in linguistic research. On the other hand, there are obviously challenges, so we still struggle and always will be struggling with finding ways how to better annotate some constructions that we didn't know about initially, or because we went bottom up, so we started with the languages for which we already had data, and then we gradually added new phenomena from new languages. There will always be issues with ensuring consistency of the annotation, because it's annotated by people make errors, so we need tools that will be able to check it. It's not always so easy. And obviously it's also challenging in terms of balance, and I will have, the next slides will be about balancing the data set in terms of languages covered. And the last thing I will have will be about various extensions to the project that people have been demanding. So first about the balance, I said we have the growing number of languages from 31 families, but if you look at the families, there is still, and there probably always will be, a huge bias towards Indo-European languages. That's not surprising, because those languages are spoken in countries where the research was funded much better, so they were privileged in that way. And we will not reject a language just because we already have many languages from the same family, right? So you can see that there is like Afro-Asiatic and Uralic and Tupian. Tupian actually is a number of languages. It's a good family, well covered. But if we instead look at the number of words, then it's a different picture, because not only we have many Indo-European languages, but we also have millions of words in those data sets, while typically for a Tupian tree bank, we would just have a few thousand, which unfortunately is difficult to change. We hope for those small languages to grow, but we cannot hope that there will be 3 million words of any indigenous languages any soon. I have two more slides showing the same thing within the Indo-European family. So even there you can see that there is a bias. The three large subgroups, Romance, Germanic, and Slavic languages, are well represented. Again, this is number of languages. So you could see many Indic languages. There are some, but not so many. You could see many Iranian languages, but we have only a handful, and so on. And again, if I instead show you the number of words, it will be skewed even more, and you can see that most of the Indo-European data sets are covered by Germanic, Slavic, and Romance. But again, this is proportional, so it doesn't necessarily mean that the others are all of them extremely small, but it means that some of the Slavic and Germanic and Romance tree banks are very large. So that was about the balance issue. So I don't think there is any good solution to this. We just hope for more people providing more data in new languages. And finally, about the extensions, that could be a talk by itself, but I just wanted to mention that people wanted to annotate other stuff than just syntax and morphology, and wanted to have a similarly universal, in the sense of covering many languages, approach. So some efforts are already within the UD project. There is a thing called enhanced universal dependencies, which you can imagine just as a layer of annotation which is closer to the meaning, closer to semantics. a very similar direction goes the deep universal dependencies. I will not now go into details, maybe in the discussion if you want to. Then there is universal proposition banks, which if you know prop bank then in English, then it's essentially trying to do the same thing. So it means for a verb trying to get its arguments and get a semantic layer like that for again many languages, and they do it actually on top of the UD data. Then we have a project called CorefUD, which annotates coreference between various noun phrases, including pronouns within a sentence. Again, we do it on top of UD annotated data, so you can compare coreference with syntax and morphology. And then there are named entities, which also is something that many people want to have available in annotated resources. And again, there's at least one project which tries to do it in many languages on top of UD annotated syntax. There is also a project called Surface Syntactic UD, which again, I don't have time into the details. They just think that the syntax should be, the shape of the tree should be slightly different, more in line with traditional linguistic approaches. But they make sure that whatever data they have can be converted to UD and back. So they actually have all the languages that we have in UD, they have in this alternative annotation scheme. Then, does it work anymore? Okay. A project called Parseem is about annotating idiomatic multi-word expressions, again on top of syntax. And Unimorph, I think Magda will be talking a bit more about it. That's another effort trying to do morphological, inflectional, and other derivational as well, lexicons for many languages. So the many languages is the part in which they are similar to UD. And that's all I had to say now. So there will be discussion later. I think I can stop here. Thank you.
Can you hear me like this? Can you hear me in the back? Okay, thank you. So, good afternoon. Closer, okay. Like this? Okay. Okay, so good afternoon. Thank you for the invitation, and thank you particularly for the invitation to the Mesa Redonda format, because as you will see, I have more questions than answers, so I'm really looking forward to the discussion part, which will follow after my talk, to listen to your answers, suggestions, and comments. Like this. So the topic of my talk is what can we learn about morphology from available linguistic resources. So I will now focus on morphological resources which contain annotations for many languages, and I will ask questions how they can be used for language typology. So currently there are more than 7,000 languages described to be spoken around the world, and language typology tries to explore and compare language structures on the phonological, morphological, syntactic, and lexical level. The challenge becoming bigger and bigger in the last 2 decades is that we can move from samples that cover tens of languages to really massively multilingual data, which are available in language data resources. So the question is how mature these resources are so that we can use them for typological insights. Dan dealt with syntax and morphology in his Universal Dependencies project, and I will now just focus on morphology and broaden the picture to show you different resources that cover different phenomena. So I will proceed as follows. I will talk about basically 3 types of multilingual data resources that are usable for morphological research. First, I will start with text corpora. Sorry, I have to. I will talk about parallel corpora, and then I will briefly mention universal dependencies again to show where they are in the picture I'm trying to draw. Then I will move on to lexical databases, which are, in contrast to text corpora, lists of words that are assigned some type of morphological information. And I will show you 3 examples of different lexical databases. In the Unimorph database, there are inflections and derivations available for many languages. Then I will mention the Universal Segmentations project, in which we try to segment words into morphemes, and yet another perspective on morphology is provided by the so-called universal derivations, in which words are grouped according to how they were derived. And to close the overview part, I will explain what is meant by typological databases. I will explain the structure of the World Atlas of Language Structures, which Dan already mentioned, and will show you how they are different from the previous types of linguistic data. And then I will move on to pose some questions which can be asked towards these data resources to learn more about morphology. So just to start, I have to stress that linguistic data resources try to cover both inflection and derivation, which are both considered subdisciplines of morphology in theoretical linguistics. So there are definitely clearly inflectional phenomena like plurality with nouns, or clearly derivational phenomena like formation of agent nouns in languages. However, there is no clear-cut boundary between these 2 areas. So it's rather a cline or a scale on which phenomena such as participles, negation, or comparatives are positioned according to their realization in the particular language, but also, importantly, also according to the descriptive tradition of that language. So we can have descriptions where negated forms are considered to be word forms, to be inflected forms of a lemma, while in other languages, in other descriptive traditions, we can see them as derivatives, right? So despite this fuzziness or this unclear boundary, the inflection derivation distinction is employed in language data resources, and particularly in the lemmatization, which is the task of assigning a word citation form. So I will use word form or token for the forms which occur in text, and citation form, lemma, or type as terms for the representative form which is used in dictionaries. And the task of lemmatization is to decide what is the inflected word form and what is the derivative, which is considered a separate item. So I try to exemplify this task by the example box on the right. So I put there a few words which contain the root right, and I try to figure out what the lemma for these forms should be. So it's probably quite uncontroversial to say that right, the verb is itself the lemma, as well road is a form of right, and rights is third singular present form of right as well. So we have there 3 forms of the verb right, so they all get the lemma right. There is the agent noun writer and writers, the plural of it, and they both will be assigned the lemma writer. There are also typewriter and rewrite, and probably they will be also like taken as separate lemmas. not as forms of the verb. But there are more tricky examples like writing, so we have to decide according to the context whether we have writing as a form of the verb, like I am writing a letter, so then the writing form will be assigned the lemma write, or if I'm using this word form as a noun, so my writing is eligible, so then I will probably go for the lemma writing. With written, again, it could be an analogous question whether I consider it a participle of the verb write, or whether I have it as an adjective, so I assign the lemma written. And what is there are writings, so writings is the plural of writing, so this is the same as the nominal choice for the second line, and then this the most tricky question of unwritten. So if we have unwritten, we can say that it's the negated adjectival form of unwritten, so we stay with the same lemma. However, we can also say that we want to lemmatize negative forms as positive forms, so we can go for written. So we will have written and unwritten as two forms of the same lemma. Or if we say, okay, we have written as the participle form of to write, so we can even make this most radical choice and lemmatize this as to write. So what I want to show by this example is that in language resources, we simply have to make quite difficult decisions, and these decisions really shape the picture we can get from the data, right? When we decide, for instance, to lemmatize negated forms as positive forms, we then simply cannot find any negative lemmas in our lemma list. So this is what we have to be aware of. We have to check in advance when using the language resources, so what we can find in them. So now I will start with the overview. So here I have the first example of a corpus. It's a parallel corpus containing 4,000 translations of the Bible in more than 1,600 languages. These corpora are verse aligned. So in the example box, you have the third verse of the book of Genesis in 5 languages. Even if this corpus is not morphologically tagged, it was used for typological exploration. So the case was that they calculated the type token ratio and took it as an indicator of the language's morphological richness. So the assumption is that morphologically complex languages will have more diverse sets of word forms. So if we have a particular number of types, so we expect in a morphologically rich language that there will be many tokens, so the ratio will be low and it will indicate a rich morphology. This corpus is very appropriate for such a research because we have a fixed set of verses, fixed set of texts, so we can be sure that the texts are the same in all the languages. So what we really can check is how different languages employ the same meaning. In other languages, this ratio would not be that informative as in this one. I have here another example of a parallel corpus. It contains more than 60 languages, but the situation is different. So corpus of each language has a Czech parallel text, but not necessarily the other languages are in parallel. So the Czech pivot is the largest one, and we can find parallels to other languages. This corpus is automatically aligned at the sentence level, and for nearly half of the languages we have lemmatization and morphological annotation. However, in contrast to universal dependencies, there is no unified scheme to annotate the sentences. So I put there an example. I hope you can somehow see it from English and Portuguese. I searched for sentences which contain forms of the verbal lemma to smile and forms of the verbal lemma rir, and what is there are the corresponding sentences. There are, maybe it's not visible, but there are text, morphological texts following the red words, and they inform us about the morphological categories of these words. However, we should be very careful here because, as I said, they are not from the same annotation scheme. So what they use are different texts. In the English text, there are treebank part of speech text, which should be read as whole. So they are consisting of 2 or 3 characters, but they should be read as labels, simply telling us what the form is. In the Portuguese corpus, on the contrary, there are used, they use texts from the Eagles project, and these texts, even though they look quite similar, they are positional texts. So for each position, we have to read each character separately and interpret it based on the table we have there. I just shortly come back to universal dependencies and just to contrast it to this project to the previous one. So what we have here are nearly 300 corpora for 161 languages in the current version, but they are not parallel texts in contrast to the previous ones, but they are different text sets, but they are annotated under a unified scheme. So they are tokenized and lemmatized. There is the morphological annotation consisting in a universal part of speech text and universal features, and then there is the syntactic annotation. So what we see in this corpus, but also in the previous parallel corpora, are word forms that occur in natural syntactic contexts, right? So now I move to lexical databases. So, and here we are in a different setting, right? So lexical databases are simply lists of word forms or lemmas which are assigned some type of morphological information in these cases. So I will show you 3 examples, 3 projects which cover many languages and provide different morphological pieces of information. The Unimorph project, which was mentioned also by Dan, is a collection of inflections and derivations from 169 languages. They are taken from dictionary, and for each language there are 2 files, one for inflection and the second one for derivations. So in the inflectional file, there is a set of inflected forms for each lemma, and in the inflected form, the inflectional ending is delimited, and there is explicitly said what categories are expressed by this inflectional ending. I will show you the examples in a second. In the derivational file, the ancestor is given for each derivative, so there is the derivative and the word which is assumed to be the base word for it, and the derivational affix is listed separately. This project is nowadays quite similar, quite close to Morphinet project, so I just name it there because it will follow also in the next slides. So here's the example. So on the left-hand side, there's the inflectional file extract for English and Portuguese. And what we can see there, in the first column, there is the citation form, the lemma. In the second column, what follows is the word form. So we have override, overrides. In the last column, the inflectional ending is separated. So you can see as separated on the first line in the last column. What remains after stripping of the ending is the string override, which can look like just the remaining string, but it's not the case. If you check the next lines, you can see that what they put there is in fact the citation form. So we have override on all the lines. So it's in fact the citation form, the full lemma, and what follows is the ending. So to go back to the inflected forms, it's not just possible to concatenate these two parts. We have to apply some phonological changes to get back to the form. You can see it also in the Portuguese example, so where the rear infinitive is put there, and what follows is the string which is assumed to be the inflectional ending. You can disagree with this. I really be happy to hear your opinion in the discussion. This is really the extract from the data, and just to illustrate what decisions have to be made when compiling such a resource. On the right-hand side, there is an excerpt from the derivational file, and it looks differently, right? So we have again a citation form in the first column, but we have a citation form also in the second column, right? So we have two citation forms. First is the base word, the input to derivation, and in the second column we have the citation form of the output of derivation. So there is the derivative, so we have writer on the second line, and there are the part of speech text of the input, of the output, and the derivational affix delimited. What is missing here is the category, right? We have the inflectional categories listed in the third column in the inflectional file, but we have just the string of the derivational affix, but not the meaning. We don't know that it is an agentive affix or repetitive prefix or whatever, right? So it is just listed. I like to compare the Unimorph project just mentioned with Universal Segmentations, which is another resource. It's a collection of lexical resources that contain words segmented into morphemes, covering 30 languages. It is based on existing language resources, so there is no manual segmentation done when compiling this resource, but it's based on what was available in the previous resources. And the resource is harmonized into a cross-linguistically consistent annotation scheme. I will show you now the example. So what we have here are just the inflected forms in the first column. So we have rewrites, then we have the part of speech, and then we have the word form cut into morphs. What we have here are really just the strings which can be put together and we get the original form. So there is no normalization, there is no substitution of the string of the morph by some citation form, what we saw in the Unimorph project, right? So what we have here are write, read, wrote as three possible, three attested versions of the same root morpheme. So what we know here is that there are some allomorphs, there is an allomorphy with this root, and this information was not available in Unimorph, right? So this is what got lost in Unimorph by replacing the root by the citation form. What is missing here, on the contrary, is the information that they all belong to one morpheme, that they are just different attested forms of the same morpheme. So that's the difference. And this is the third example of a lexical database containing or providing, again, another type of information about morphology. And this is the Universal Derivations project, which focuses on derivation. So it is a collection of lexical databases that try to describe derivation in a cross-linguistically consistent manner. They currently cover 21 languages, and they proceed as follows. So the aim is to identify words that share the same root. In the example, in simple example below, there is angel, angelic, angelical, and angelically for English words that contain the same root. And we want to organize them according to how they increase their morphological structure, so how they were derived. So the idea is that the simplest word, angel here, will be the root of the tree, and it will be followed by the word which contains one morpheme more. So we have angel, supposed to be the base form to derive the angelic adjective, then it becomes the base form for angelical, and we end up with angelically as the adverb. This is just the example. When we apply this scheme to real data, we end up with structures like these. You probably cannot read the words, but I just comment generally on the trees. So I should stress that what we had in this project are again resources that were harmonized into the common annotation scheme. So depending on how rich the input resources were, so we have richer or simpler trees in the Universal Derivations project. So in the Portuguese example below, you can see that we had just a simple resource, nominalics for Portuguese, where we had verb with two types of nominalizations, agentive nouns and action nouns. So these trees are just simple, similarly to demonet, which is for French. But for Spanish, this derinet es, the structure is richer, and we can see that we have a more complex tree. The most complex tree there is the derinet, biggest tree for Czech, and this is because this resource is based on a sort of complex morphological dictionary which targets at covering the whole lexicon of Czech. So the aim is simply to organize all the words we find in Czech into derivational trees, and what is visible in here that Czech uses many prefixes and suffixes to derive words. So we have morphological families that contain hundreds of words. And here is the last type of the morphological resources I like to mention, and these are the typological databases. In contrast to corpora and lexical databases, they do not contain language material. They do not contain words or sentences. What they contain are linguistic, like meta features, phonological, morphological, syntactic, and lexical information about languages. It's a database containing information for 2,662 languages, and there is a print screen for the web page for Portuguese. So in the features, again, probably you cannot read it, but there are it starts with phonological features, and in the morphological part, there is information about inflectional morphology that uses suffixation rather than prefixation. There is no reduplication used for morphology, and in coding plurality in nouns, plural suffix is used in Portuguese. And what follows are some 50 more features telling us how Portuguese expresses morphological, syntactical, and lexical phenomena. There are more typological databases. I name here just two more. GramBank, which is a follower of VALS, and a more focused atlas of Pidgin and Creole language structures. And there are also efforts in putting different databases together to be able to search them in one place, and these are these so-called metadatabases, autotyp and URL. So how can these resources be used for typology? So I start with questions concerning typology of inflection, and it's similar to what was shown in Dan's presentation, that we can definitely look for answers to old questions. So Dan showed the example of looking into the word order. Here I suggest that we can find answers about inventories of inflectional categories and their values in many languages and with more specific insights. What is also available in the databases is the information about mutual relations between and among the categories or values. But there are definitely also questions which have not been posed yet because there were no data for answering them. And this is about the attestation of individual categories and values. So for instance, if we know about a language that it has some 20 case forms, it does not mean that they are all necessarily used in language. So we can use language corpora to really see which of these case forms are really attested and which are not used in that language. If we have this morphologically segmented data, we can have closer insights into morphological complexity of inflected forms. An even bigger space for exploration is in the area of derivation and word formation. I haven't mentioned it yet, but maybe it could be seen already in the overview that inflection is preferred to derivation in language typology as well as in language data resources. So we have more information about inflection than about derivation. There are basically two pioneering books on typology of derivation and word formation. It's an emerging discipline. So in Steckower's book 12 years ago, the attestation of word formation processes across 55 languages around the world is described, and it is followed by a study of derivational networks, very much in line with what was shown in Universal Derivations. These derivational networks are compiled for 40 languages, and we can see how derivation is exploited in these languages. However, there are questions which have not been answered and wait for some more detailed and more authentic material, like which processes are employed in the languages, which are prominent and which are rather peripheral, or what are the affixed inventories for particular derivational meanings. And if I just abandon this split between inflection and derivation, we can ask more complex questions concerning the relationships between morphology and other linguistic phenomena, or between inflection and derivation. So it will be definitely possible by using resources that contain multiple types of information, of annotation, as we've seen in Universal Dependencies. And there are also efforts in interconnecting resources containing different types of annotation. What we expect to see are relations between inflection and derivation, inflectional categories and syntax, and between word formation and syntax. To conclude, I just sum up that I reviewed different types of multilingual resources that can be used for the study of morphology. I divided them into 3 groups. I gave examples of text corpora, lexical databases, and typological databases. And I tried to point out that there are quite many design decisions that have to be made when compiling these resources. First of all, we have to decide selection of languages, sample size, and coverage in terms of type token frequency. Then the next step is to decide which annotation scheme will be used, and the most practical and usually the most difficult task is then to apply the scheme to individual instances by being as coherent as possible within and across languages. And all these decision steps definitely affect the picture we get about languages from the data. So thank you for your attention, and I'm looking forward to the discussion part.
So, we have now time for questions. I would like to ask a question myself to both Magda and Dan. We have seen that many of these frameworks use the term universal, which is a central concept in other linguistic traditions, for example, in generative grammar, and also in the linguistic typology of Greenberg and followers. One interesting advantage of universal dependencies is the rich ecosystem of tools to manipulate treebanks. And as someone who has constructed a treebank of Nyangatu, I can say that the two validation tools were very helpful, because there is a validator which decides whether a treebank will accept it in a release of universal dependencies. And also there is a framework called UDAPI. I don't know if this is the way people pronounce the name of this framework. This is a Python library which checks for errors. So, and some errors are not ruled out in the validator, but they are catched by the UDAPI framework. For example, the validator does not accept two subjects governed by a single verb. This is considered an error, but the validator accepts two direct objects, but the UDAPI library rules out two objects, but it doesn't rule out two indirect objects. So, my question, how do you see the field, whether there is a convergence between this research in universal and this attempt to automatize universal concepts which are possible or impossible in natural languages? In all fields of analysis, from syntax to morphology.
Okay, so does it work? Yeah. I would say that, first, the observation about using the word universal is a very good one, and it's actually, I think that's another, even if small, but still aspect of universal dependencies which may sound at least provocative to many linguists and especially typologists. And it's probably why we call it universal or why we dare to call it universal, was that in the beginning the UD community was prevailingly made by people who were doing natural language processing, were part of them were just computer scientists, and other were like computational linguists, but not necessarily typologists. So it doesn't sound to them so daring to say that something is universal. And I think, in a sense, you can take it more as a marketing term. So it's universal in the sense that we want to be able to apply the same scheme to hopefully all the languages of the world. And if we find out that some of the languages don't fit well, then the scheme will just be adjusted to be able to capture them. But it's definitely not a claim about any universal concepts in which some typologists would actually disagree that they exist in the first place. So you maybe people would better want to talk about comparative concepts or something like that. So universal really should be taken with some reservations. But as you also mentioned, you could see universal in the terms of the tools that you can apply a sort of language agnostic way to many languages, and that's the parsers, that's the validating infrastructure. You said UD API, that's definitely one of the correct pronunciations of that tool. I usually say UDA pages because I heard the author of the tool saying it that way. And yeah, that's a tool where you can essentially access the data and either use some pre-programmed blocks, not only for looking for errors, but also to actually search the data, find interesting patterns, maybe even modify the data. So that's the tool which is used by people who maintain the treebanks as well. But there are many other tools. So I think like having something using the same set of guidelines has many practical advantages, and that's what's universal about all these frameworks, I think, that we mentioned here, like not just UD, but unimorph, universal derivation. I think after UD started, it became fashionable to call your project universal something, to just signal that you have similar motivation to create something that will be useful, some kind of language resource which will be hopefully practical for as many languages as possible, regardless of their typological differences, if that answers your question.
I definitely agree with Dan that it's a label, and it's a successful label in case of universal dependencies, definitely. But I would also dare to say that it's sort of like loosely pointing out the relation to the assumption that universal characteristics of languages can be like recognized by exploring as many languages as possible. So these are maybe like common idea behind all these resources, that if you are able to design a scheme which is in many cases underspecified to be able to fit to as many languages as possible. So once we have as many languages as possible in one place, sharing the same annotation scheme, we will be able to observe some features that are simply shared by them. So I think it's at least a bit theoretical as well.
Hi everyone, thank you for your speeches. I'm Anthony, I'm a master candidate in linguistics at Universidade Presbiteriana Mackenzie here in São Paulo. Leading my research, it is focused on plain legal language, and one of the topics I take a little dive in is how to apply computational linguistics to make legal language clearer. And during your speeches you mentioned how you use annotation and other resources to identify the language and even preserve indigenous languages and so on. In Portuguese, we have this issue that I believe in legal language in general, even in English or Spanish or other languages too, we have this polysemy, where a same word that is written equally means different things within different contexts. So if I say partition in a general context in English, it means A. If I say partition within a legal document, it means B. So those are the so-called legal terms of art. I would like to know from you if during your research or practical work, if you have faced a situation regarding technical texts where some words had different meanings at the same time, this polysemy, and if this has affected the work that you have been developing, or the ability of the AI solutions to properly process and identify the language used within the text, or the meaning of these specific words within different contexts. Thank you.
Thank you for the question. It's a very difficult issue, not only polysemy, but also homonymy and other like mismatches between meaning and form. So it's definitely an issue we have to deal with. And it depends on the resource. So if one compiles a resource which contains inflectional information and a polysemic item does not change inflection in the particular senses, so there is probably no reason to split the item into more items, right? So if we define simply how it is inflected, we state what case it is, what number it is, and so on, so forth for nouns. If we have the derivational resources, so it can happen that polysemic items have derivations only in some senses. This is quite difficult to describe, but for these cases one can introduce some indices to say that we distinguish more meanings, or we split it into like more lexemes, and we then describe the derivational path for individual senses separately. So it really depends on the resource and on the perspective on the meaning you describe, and for some types of resources it's really difficult. I think it's a bigger challenge for syntactic relations, and even more for annotations which try to figure out what the meaning of the sentences is, rather than for this morphological data. So Dan, if you want to add something.
Yeah, sure. So, as you mentioned, polysemy is one part of the difficulties here, but definitely, at least in some languages, it's syntactically difficult as well. The legal language is a very specific domain, and as you know, it's sometimes very important to interpret the sentence correctly. So, we have actually, I'm aware at least on one UD treebank in Czech, which is specialized in legal text. It's actually the annotated version of the accounting law that we have, and it's very specific language. Also because it's not always just about syntax, it's sometimes just that you have very long sentences, complex sentences, sometimes slightly changing topic or referring to previous paragraphs and so on. And so it's difficult actually even for the automatic parsing tools that we have. So unfortunately, I think it's a resource which is, and I think in other languages there are similar datasets as well. So it's a resource that's interesting for studying such type of text, but I am afraid that it's difficult for the automatic tools as well. So they will probably not be reliable enough to give you the proper analysis of such a text. And then there are various things that can change the meaning quite significantly, right? You have like scope of negation, and if it changes, then the law is different and probably is not what you want. Scope of modal verbs and other things. So I would say, yes, it's a problem. Some of the resources we have might help you to look at the problem, but not necessarily to solve it.
Hello, thank you for your presentations. I have two questions. First one regarding the exploitation of the corpora. If you have systems to do queries online, or if you have to use some sort of program, software to do that. And the second question, if you have some connections, you just mentioned about intersentential relations. So information structure, I know about Hajchova's work in Czech Republic, so an author who is very important in the Czech Republic on information structure. If you have resources on that comparatively too.
So, as for the first question, I think that's the easier one. Yes, there are search engines, search services. So you can use some of these services online. There are multiple, not just one. We have one in Prague, and there is another one very well maintained in France. You will find links to some of them on the Universal Dependencies website, and you can. The querying is not always easy. It depends on what you want to find. If you want to just find me all the verbs and their lemmas and give me the list, then it's easy. But if you want something complex, then you will have to read the manual how to do it. And obviously, yes, you can also do it locally. You can download the data, and if you can program or if you can download a program that will do it, then that's an option too. But I think that's for advanced users. So using the online search engines will be probably easier. As for the second one, I think topic focus articulation, this information structure, that we have a resource in Prague, but I don't know about other languages.
Yeah, I would say cool that you know this issue. So it's interesting, but maybe I can add like a theoretical remark that in the framework Hajchova is working. This information structure is considered part of the semantic structure of the sentence. So what Dan presented here are universal dependencies which focus on the so-called like surface relations, right? Like subject-object. And in some projects, and they are not that multilingual that we would tell you about them today, but there are developed for some languages. So they add the semantic level on top of these surfacey relations. And the framework Hajchova is working in is implemented in Prague dependency treebank, and in this treebank information structure is part of this deep syntactic layer. So there are definitely data for Czech where the annotation is available for tens of thousands of sentences, and there are parallel corpora Czech English, for which I'm quite sure information structure is also part of it. And there are some other projects which deal with information structure for other languages, but they are not connected to the Pragian resources. So if you are interested, I can give you definitely links to the data where information structure items are present, but it's not in universal dependencies because it's like considered to be part of the deeper layer of the deeper semantic structure. So I don't know if it's planned to have it as a part of the enhanced dependencies, but
not that I know of it.
Okay.
There might be people willing to do that, and then it would be yet another item on the extensions list that I showed at the end of my presentation, but I haven't heard about people trying to do that right now.
I think we have 4 minutes. No? It's time for maybe another question.
I'd like to say that the fact that universal dependencies, treebank, are taking care of some Tupian languages and working well, and we are working here with Caduel from a very different family, using the UPenn treebank kind in tags. True that we had to add some rules and some tags, but still, I mean, it's working well and generating the language and annotating the language. So I think that we are on the right track to look for universal ways to annotate languages.
Thank you. We are definitely looking forward to it. And I would add one, maybe another observation that while having already your own annotation in the pen treebank style might be enough for just your project, as we just mentioned, the possibility to look for data in the search engines for the different languages. So being in part of UD would add another layer for the users here, because imagine you are looking for some particular construction and you learn how to query for such patterns while researching one language, and then you just can take the exactly same query and copy it and ask the same thing about Kadiveu or any other language, and if the construction exists there, you should get the results because it will be annotated the same way, so the query will help you as well.
So, there are still 2 minutes left. It seems that there is no questions. I think both speakers and the people who are here and listen to the talks. Thank you very much.